Hey guys, welcome to another video for anatomy and physiology. In this video, we're going to be taking a look at the muscular tissue. There's three types of muscular tissue. We have smooth, cardiac, and skeletal. We're going to be looking at slides for the three types and differentiating them by their function, location, and appearance under a microscope. So let's first take a look at the skeletal muscle. This is probably when I say muscular tissue, this is probably the first type of muscle that comes to mind. And this is the muscle that is under voluntary control, meaning that you control it. You have conscientious control over it. So as we look at it in a microscope, one of the first things that you'll probably notice is the long horizontal sections. And each of those sections that's interrupted by the white space, which is a plasma membrane. Each of those is a muscle fiber, and you'll notice that they're long. There is no branching of it. It's just long thread-like muscle fibers. And then another thing that you'll notice, as I mentioned before, it's unbranched, and they're relatively parallel. Not perfectly parallel, but for the most part. And the other thing that you might notice is the striations. Now, it's kind of subtle, but you may look like it's a mistake in the slide, but if you look very closely at each one of these muscle fibers, you're going to notice an alternating dark and light coloration. It's dark, light, dark, and this is in every single one of the muscle fibers. Now, later on, when there's an entire chapter dedicated to muscle tissue. We'll go more in depth into what those differentiating colors are. But just for now, notice that each muscle fiber has an alternating dark and light striation. Okay. Now another thing to notice is the very dark oval-like shapes that you see, the dark blue or purple. Those are nuclei, and each muscle fiber has multiple nuclei per cell. And you'll notice that the location of the nuclei are kind of on the outside near the plasma membrane. So as I mentioned before, skeletal muscle is involved in body movements, facial expressions, posture, breathing, swallowing, speaking, urinating, controlling urination, defecation, and it's also in voluntary control. So that's the muscular tissue. Now next, we're going to look at cardiac muscle. And when we stop to consider the special job that the heart has, it makes sense that it has a specialized type of muscle cell. And we're going to look at some of those special, unique features that cardiac muscle has to the other types of muscles that we talked about before. So cardiac muscle is also sometimes called myocytes. Myo prefix meaning muscle, site a muscle cell, or also a cardiocyte, okay, referring to its location in the heart. So sometimes it could be cardiac muscle fibers, or like I said, myocytes or cardiocytes. So one of the first things to notice here that's different from the skeletal muscle is that myocytes are branched, okay, and they're also notched at the ends, and there's one nucleus per cell. So from one notch to the other, that's what we would consider a cardiocyte, and each one of those cells contains typically one nuclei, okay, and it's usually around the center of that cell. And that nuclei is also surrounded usually by like a white space that has glycogen surrounding it. Glycogen is a sugar storage, and again, consider the how many times a heart beats per minute, per day, per week, per year. The heart requires a lot of glucose, so it has a really good amount of glucose or glycogen storage there for energy. So cardiac muscles or myocytes are joined at the ends by an intercalated disc, and those are those dark lines that you see that differentiate one cell from the other. Those are intercalated discs. Now these junctions, these points actually allow the heart to be able to conduct electricity from one cell to the other at a much faster rate than normal. And again, while I'm saying all this, consider what the heart does every day, all day long, even while you're sleeping. So it allows for a wave of excitation of electrical impulse to travel through it much faster, much more rapidly. And it also allows it to stimulate all the cells all at once. Okay, so the cells are also shorter typically, consider them skeletal muscle, how they were long, unbranched cells. Well, these are shorter, and again interrupted by the intercalated disc. Now, one of the things to notice also, and this is actually a similarity that cardiac muscle has to skeletal muscle. If you look really closely, you'll notice those alternating dark and light lines, those striations. Okay, we already kind of talked about the intercalated disc, and you can see those highlighted right there. Now, not every muscle slide will have the intercalated disc this pronounced. You have to actually stain it in a particular way to have these pop out a little bit more. So this is actually a pretty good slide for that. Okay, so 1 nuclei per cell. We talked about that. And so now we're going to go ahead and move on to smooth muscle. Now, one thing about smooth muscle that's similar to cardiac muscle is that it's involuntary. You have no control, for the most part anyways, you have no control over your heart pumping, these muscles contracting. Okay, so when the muscle contracts, likewise with the skeletal muscle, when the muscle contracts, it shortens. And then when it relaxes, it elongates again. So with skeletal muscle, it's voluntary. You have conscientious control. And with the cardiac muscle, you have no control over that. That is just, it goes without you having to think about it. All right, so let's go ahead and transition to smooth muscle, another involuntary muscle in the body. So as we take a deeper look into the smooth muscle, let's look at some of the features that differentiate smooth muscle from the other muscular tissue. So one of the first things is, as you look at the appearance of smooth muscle, it has a short fusiform cell-like shape. So fusiform is a word that essentially means that it's going to create this shape that you see here. So it'll have on both ends, it'll kind of converge, it'll narrow down, and then there'll be a small belly in the middle. And in that belly, it'll be non-striated. Okay, so if you think about what the muscular tissue for cardiac and skeletal muscle look like, as you look at this particular slide, you don't see any striations. There's no alternating dark and light lines. And there's also one nucleus per cell. Now, because this muscle is kind of squished together, it is kind of hard sometimes to differentiate or find that fusiform. Some slides will show it a little bit better than others, but you can kind of see here they're all kind of sandwiched in together. And that's clearly very different from smooth and cardiac. So that's one way that you can differentiate smooth muscle from the others. And these control contractions of the stomach. So this muscle is primarily involuntary muscle, which means you have no control over it. You have no conscientious control over how smooth muscle works. And so one of the functions is that it helps in contraction of the stomach. So when you look at the anatomy of the stomach, and we will later on, you'll notice that there's different sheets, there's different layers of muscle running in different directions. And that's because that stomach muscle is churning up all the food that you've consumed, and it's helping break it down and digest it. And you have no control over that. In addition, labor contractions, you have no control over those. Pupillary diameter, so it helps, this smooth muscle that's surrounding the iris pulls on the iris, and it allows it to either contract or to dilate, depending on how much light is there. And it's typically, as I mentioned before, under involuntary control, so these are all things that you don't control. Now, for the most part, smooth muscle is a visceral muscle, which means that it forms walls around the digestive, respiratory, urinary, esophagus, and small intestine. So visceral, the word visceral means that it's in direct contact with these organs. So you have the organ tissue, and then you have the visceral tissue, which is the muscle that is in direct contact with this. So with the digestive, respiratory, again, these are all things that you're not even thinking of usually throughout the day. There's a term, peristalsis, that you'll become very familiar with. Peristalsis is the contraction, the wave-like contractions of muscles. So as the muscles are wrapping around let's say the small intestine, as they contract in a wave-like motion, they're propelling the material that's inside of there in a certain direction. And that's, again, stuff that you don't really think about. In your esophagus, when you're swallowing, okay, when the food gets into your throat, your esophagus is contracting, it's going through peristalsis, pushing the food down. And then as well, it also regulates the diameter of blood vessels, controlling blood pressure and blood flow. Again, things that you're not even really thinking about. And then finally, it forms sphincters that control the emptying of the bladder and the rectum. So a sphincter is basically a circular muscle. It's a tight muscle, a tight space, and it squeezes, it shuts down, or it opens up depending on if there's pressure from the other end. And it's just it's a circular. It's the muscle that's in a circular shape, and it controls the excretion of urine or food in the rectum. Okay, well, that does it for our muscular tissue. Again, you have smooth, cardiac, and skeletal. Do take the time to make sure that you can differentiate by the different locations and the features, because if I mentioned it's completely fair game in quizzes and tests. So thanks for watching, guys, and good luck in your studying.